Good morning, grade 10s. I hope you guys had a good weekend. So this week we are covering map work. How are you guys feeling about so it's basically map work revision. So I'm assuming that you guys did map work in term 1. How are you guys feeling about map work overall? Guys, are you there? How's everyone feeling about map work? Are you guys feeling a little bit confident? Are you ready for the exam? Did you cover quite a bit of map work in term 1? I just need a little bit of information. Okay, I guess no one's going to respond. Okay, guys, so today we're covering a GIS, and there are no issues. Okay, great. Thank you. Thank you for responding. So we are covering GIS, and next week we'll cover map work, the comprehensive exercise that was sent to you in the week. So guys, just because it's quite a congested lesson for the next 2 weeks, I would really advise going through the PDF before we started our lessons each week, just to be able, if you've got any questions, then we can quickly address them in the lessons. Great. So let's move over to GIS. So what is GIS? So the development of a geographical information system. So imagine if you could look at a topographical map of your town and not only see all the schools in your town, but you could point out to each school and get information about it. So, for example, you can see how many learners there are in each classroom, how many sports fields or social clubs there are, as well as who the principal is, things like contact number, etc. Next, you might also want to find out what facilities are next to each school, so such as nearest parks, recreational facilities, public transport hubs, etc. So the easiest way to do this would be to create a map showing the location of all the schools, transport hubs, parks, and other recreational park. And this way, you could easily see which school is best served by these facilities. Obviously, a topographical map, the traditional topographical map, does not allow you to view extra information about a place or create new map layers. But with a GIS, you can do this. A GIS could also analyze the information for you and calculate which school is closest to the most services. Now, a GIA can also do these things because it uses modern computer technology to obtain, manage, and display geographical information. And a GIS also displays geographical information in the form of digital maps that can be updated, modified, combined according to the user's needs. If we look at this illustration here, we can definitely see that a GIS uses specific components in order to capture, manage, and display geographical information according to the user's needs. And that data is captured, stored, managed, and processed, and later displayed. Great, guys. Are we comfortable with that? Having seen that, can you guys think of anything? Does anything pop up? Any systems that we currently have that are using GIS? What about you, Google Maps? Okay, great, guys. There is an activity here about getting to know GIS. So, for example, you would explain what GIS stands for and basically explain what each word tells us about a GIS. You would also list 3 factors that lead to the development of a GIS. Explain the advantages of using a GIS to solve geographical questions, and lastly, make a list of 5 professions in which you think a GIS could be useful. Please feel free to do these activities and post on LMS. There should be an option to do that. If not, please send me a message on WhatsApp, and I will see what to do there. You'll also receive a memo just before either on Friday or next week on this. Yeah, there's quite a few activities, guys. Please take some time to do them. Okay, let's move over to remote sensing. So, what is remote sensing? It basically involves collecting information about the Earth's surface from a remote location, that is, a location that is not in contact with the Earth's surface. Remote sensing includes aerial photography, satellite imagery, and solar scanning of the Earth's surface, water masses, and the seafloor by instruments on satellites, aircraft, ocean buoys, and ships. There are 2 types of remote sensing data, and the data is captured by recording different wavelengths or frequencies of of the electromagnetic spectrum that are emitted by the Earth's surface. Great, guys. You can read a little bit more about how remote sensing works in your own time. Let's look at the 2 types of remote sensing. So we've got active and passive remote sensing. So passive remote sensing involves instrument sensors that simply record the radiation reflected from the Earth's surface. For example, a camera recording visible light reflected from the surface of the Earth, and an infrared sensor that records emissions of infrared data. And the active remote sensors send a signal to the Earth's surface and then record how it is reflected back. For example, aerial photography and a radar and a microwave satellite sensors, they emit a radio wave signal that is measured on return. The frequency of the return signal and the time that it takes to return provide information about the shape, form, and extent of the feature or features that reflect the radio waves back to the sensing device. As illustrated in this image here. Cool. Yeah, so you can also read a little bit about applications of remote sensing there and what remote sensing is used for. Then we also have an exercise there, which is activity 2 on exploring remote sensors. Please go through that as well. Okay, so what components do you need in order to operate a GIS? So you need hardware, software, data, and operating personnel. I have added just more explanations on that and how each basically how each concept works and how they all work together in integration. With that, we also have activity 3 on identifying GIS components. Cool, guys. Are we all happy with that so far before we move on to data capture? Guys, I need a little bit more interaction. I need to know that you guys are there. I need to know that you're understanding. I need to know that we are on the same page. Because if you guys are quiet, then I don't know whether you guys are understanding the concepts. Okay, great. Thank you. Cool. So I will take it that everyone also understands and is happy to move ahead. Great, guys. So let's look at data capture, right? So there's actually two different types of capturing data. So we can capture spatial data. So we use digital maps in GIS, which are obtained from a variety of sources. So we can use traditional print maps, satellite images, aerial photographs. And with that, we can create a contour map of spatial data. And then okay, great. So here in the raster format, an image is composed of rows and columns of cells. It looks more like a blocky digital photograph than a standard print map, as you can see in this figure. So each individual square or cell is called a pixel and is given a single value describing the feature it represents, for example, whether it's water or it's trees. A group of pixels sharing the same value combine to form an image with a two-dimensional extent. So, for example, a forest or a dam. And a single pixel might represent a feature with a mono-dimensional extent, such as like a well point. Cool. And then if we look at figure 147, so here we are able to see how individual maps can be combined in order to create a new map overlay. So guys, let's take a look at the advantages of a GIS. So a GIS offers many advantages for manipulating geographic information and solving geographic problems. So, for example, it can capture and link digital information from various sources. It can convert geographically referenced digital data into map form. It can convert from one map projection to another, and it can also change from a large to a small scale map. So, from lots of details to less details. It can select and layer maps showing different variables. It can build a customized map from only the features that the user needs. So, using those overlays that we spoke about. It can call up attribute data about any feature on a map. It can update maps as events occurs. So, for example, by mapping a flood event such as the one that occurred in Brisbane in 2011, this has an enormous advantage for emergency and disaster relief planning. Lastly, GIS can also measure, calculate, model, and predict using sophisticated computer software. So yeah, guys, that's everything on geographical information systems. So just before I sum everything up, are you guys comfortable? Are you happy with where we are right now? Great, thank you guys. So I'm just gonna quickly share a summary for today. Okay, great. So, what do we know about geographical systems after what we covered today? So, we know that a geographical information system is an interrelated system of computer hardware, software, and geographical data that a user can use to capture, store, update, manipulate, analyze, and display geographic information. GISs were developed to make it easier for people to investigate spatial relationships and patterns and trends and to work with complex sets of geographical data. To operate a GIS, you need hardware, like we mentioned earlier, software, data, and operating personnel. A GIS can obtain and link information from a variety of data sources. This is known as data integration. This information may then be represented in the form of digital maps and attribute data. A GIS stores and digitizes spatial data in vector and raster format. Remote sensing involves collecting information about the Earth's surface from a remote location. This can be active or passive. Guys, you have this in your notes. I did send through the grade 10 MapWork revision on WhatsApp. If you're not on the WhatsApp group, please let me know, guys, so that I can add you. Yeah, but that's definitely it. Yeah, that's everything from today. Guys, if you don't have any questions, you're welcome to exit the class. But if there are still any other questions, please let me know and we can deal with those. Okay, great, guys. Thank you very much. You have a lovely day further and a great week. Happy learning, and we will catch up again next week. Have an awesome day.